Okay guys, I want to make a quick video for this unit, and this unit is 11.3, and we're talking about composite figures. So as you can tell from these figures, a composite figure is basically it's a diagram or a figure that you can separate them. So they can be separated into various regions or various sections that are plane figures. So you can see there are rectangles, there's trapezoids, there will be parallelograms, triangles, circles, anything that will make you relate to all the information that you have already obtained and use this information to build little pieces, each piece back, and then add them back together. So in this unit, we are going to study how to find the area of these composite figures. And to do that, we have to divide up the regions, find the area of each region, and then find the sum of all the areas. Okay, so here's an example. I have the first figure in here is a rectangle, and I have a trapezoid. So I need to find the first area, which is base times height, and my base is 23, my height is 12, and I should have 276. And now let's find my second area. My second area is my top base plus my bottom base, which is 23 plus 15 divided by half. I have my average base multiplied by my height. This height should be here, right? I don't have this height, but I can extend this over and find this blue segment, and I simply use 18 minus 12 because I know this part is 12. So that's 18 minus 12 would give me the height. And if I do my calculation right, this should come out to be 114. So my last step is simply to add the two together and gives me a total area of 390. And the unit, because it's an area, it's square cm. The unit is centimeters. Okay, so just to recap, divide them up, find the familiar plane figures you know how to calculate the areas, be careful with which formula you use, and then add them up together. So let's look at number 2. Number 2, I have two areas as well. I have a parallelogram right in the middle, and over here I have a half circle, and over here I have a half circle. So together I have one full circle, right? How do I know these two half circles are exactly identical? Because I have a parallelogram in the middle, and I'm given the radius here is 6, therefore my diameter is 12. This is 12 as well, because they're parallel and they're congruent by the properties of parallelogram. So let's calculate the first area. First area is simply base times height. My base, be careful, very often kids like to do this. They see a number here, base times height. Incorrect. That's half of my base. I need the whole base, 2 times 6. Okay, so that should be 60. And my second area, the formula is pi r squared. R is 6, r squared is 36 pi. And it comes out to be, I think it's 113.1 if you use pi. And again, you add the two together, you should have 173.1. Okay, let's look at this one, number 3. Number 3 is a little tricky because it's got 3, and it appears not all information is given. So I have a rectangle, I have a triangle, I have a half circle. Let's do that one by one. Okay, So the first one, rectangle, I like what I see here. I've got the width, right? I need the height, or I need the length. So how do I figure out this length here, though? I'm not given anything. And it appears that I don't know how to calculate this length. So let's do L for length. Okay, so in order to know this length, so let me write this out. I need to know length times width, or base times height. I don't know the length. I know the height is 9. See if I can find out. I need this to go from here to here. I know this is 26. How can I find out this portion? And if you notice, if I extend this from the center of the circle, this blue line is my radius, isn't it? So is this blue line. These two are my radius. And if this is 9, this must be 9. If this is 9, 26 minus 9. So my length is 26 minus 9. And I should have, what do I have? I should have 9 times 17 gives me 153. That's my first area. Okay, now let's look at my second area, which is this little triangle here. So triangle is half of base times height. Do I have the base? I have the base here, which is the radius, so that's 9. Do I have the height? I don't have the height. Let me change the color. But the red part is 7. Now I know this part is 17, so I can simply use 17 minus 7, which is 10. 10 times 9 divided by half, I have 45. So that's the second area. Now I calculate the third area, so much easier because now I have everything, right? Area of a circle is pi r squared. I have a half circle, so it's half pi times 81. I should have 127.23. So if I add all 3 together, 1, 2, 3 together, I should have 325.23 square feet. That's how we calculate 3. Number 4, believe it or not, it's a lot easier than number 3. I have a triangle and I have a half circle again. So let's look at the half circle. I have a diameter of 16, which means my radius is 8. So half circle is pi r squared divided by half, right? So it becomes pi r squared is 64. So my final answer is 100.53. That's the first area. My second area, I have the base here. So it will be base times height. Base is 16. Height, I don't know. But if I construct a line here, whoops, that's supposed to be straight. Because these two are congruent, so if I connect this dot to this vertex, right, I know that these two are equidistant, and this is my perpendicular bisector, and I've got a right angle there. So if this is 8, this is 17, I can simply calculate, let's call this height, right? So we use h. So I'm going to do a sidebar calculation here. So h squared should be 17 squared, which is the hypotenuse, minus 8 squared. So h squared, that is, h squared comes out to be 225. If I take a square root, I would have 15. So now I go back to this and plug it in. And voila. Oops. Ooh, be careful. I have to base times, I have to divide it by half. I calculated the I calculated the rectangle surface rather than the triangle. So triangle is half of base times height. So my final answer is 180. Again, if I add 180 to 100.53, 120, I should have 220.53 cm squared. That is my final answer. All right, so that's this page. Here's my final answer, let's take a look at the next one. So this one is a little harder, but it's not terrible. So again, I have three areas. Probably go for the easiest one. Square is right here, and then trapezoid is here, and triangle is there. By the way, it doesn't matter which one you start with, but it's likely sometimes you start with one shape, then you get stuck. You don't have enough information. Leave it there, like what I did earlier. Do a sidebar calculation, look for the information you need in another area, then come back to it. It's okay to do that. Okay, so let's see. If I want to calculate the first area, what do I need to do? First area is here. Do I have the square? Do I have the height? Because it's a square, it's side times side. I don't have anything. Geez. Okay, so I obviously need one side. I'm gonna call this x. Let me do this way. I don't have this, so I'm gonna call half of this x. This half is also x, right? So my square should be 2x times 2x, which is 2x squared. How do I find the x though? The reason I put it here, let me erase this part a little bit so that you can see more clearly, because unfortunately I put the 3 there. I want you to see this height for the triangle is 9.6. Okay, and this is a right triangle, and this hypotenuse is 12. So I can find x by using 12 squared minus 9.6 squared. I have a Pythagorean theorem there. If you use your calculators, you should come up to be 51.84. You take a square root of that, you have 7.2. If 1x is 7.2, 2x must be 14.4. So now I can plug it back into my 2x here and square it. My first area is done. And I should have 207.36. That's my rectangle. Okay. Let me do 3 first, because I already, the triangle, this is my number 3. Because now I already know the base, right? It's base times height. The base is 14 times 4. The height is given 9.6. That's an easy calculation. So that would be 134.2. That's what my calculator says. I always forget to divide it by half. Don't forget, base times height divided by 2. Hold on a second. Base times, yep, that's right. And then now let's look at my third section. I'm sorry, my second. I do these videos in the morning and sometimes before I have coffee. So, all right, so let's look at this trapezoid. So I already know this is 14.4. I know that the bottom base. What I don't know is the height here. I need the height here. But the height is simply 25.4 minus the 2x, right? So it should be the top base plus the bottom base divided by half, give me the average base, times the height. The height, like I said, is 25.4 minus this number here, 14.4. So that gives me 11. And then that's a decimal point. So I should, oh, I'm sorry, I made a mistake here. This one is 134.2. This one, I'm gonna use a red ink here. This one is not. This one is 69.12. So make that correction there. Okay. Now you just need to add the first area, which is here, second area, third area. Add them together. Your final answer should be 410.68. And that's square meters. Okay, so that's how you calculate the composite figures. The next section is about shaded regions. So I want to know the areas for the shaded region. You just go the opposite way. You find the area of the total area. So you want to find the entire area, entire figure. In this case, it's the square. Then you subtract the other shape. You subtract the other shape that's not shaded. So in this case, you just calculate, this is an easy one. So you calculate the area for this square, which is 25 squared. And then you calculate the area of the circle, which is pi r squared. And that's pi times 25 divided by 2 gives you the r, right? And then your final answer, that comes out to be 625. This comes out to be 490 point something, 87. So it's 625 minus 490.87 gives you 134.13, and your unit is a square feet. This, I'm not going to do this for you, but same thing, rectangle first, then triangle. This one is a right angle, right? Remember we learned about that. So you have a circle, and then when the vertex, when the if you use the diameter as the hypotenuse, and if the vertex is on the edge of the circle, you always have a right triangle. So you may have to use, I haven't done this, but I think you may have to use Pythagorean theorem to find the diameter. And this one is the same thing. Why don't I do number 9 for you? It's a little bit more challenging. So number 9, I need to find the trapezoid first, right? So if I need to find the trapezoid area, I need the top base, I need the bottom base. Excellent, I have both divided by half. I need the height. Ooh, I don't have the height. So let me do this. See, here. This is the height I need to see. Oops. Right? This is the height. So I don't have that. I'm just going to leave it there for now. Okay? Maybe I can simplify this. 17 plus 3, 4, 54. 54 divided by 2 is 27h. That's what I need. Now, how can I find the height? So you can, some people assume that this is just 17 because this looks like a square. You cannot make that assumption. You have to calculate it. So notice that if I have my height, I have my right triangle, I have my hypotenuse, I don't have this, but this part is 37 minus 17 should give me 20, right? So if I do a sidebar, I could have h squared equals 25 squared minus 20 squared. So h, if I do my calculation, h comes out to be 15. And now I can plug it back in. It's 27h, 27 times 15 should be 405. Bingo. I've got the trapezoid. Now I just need the circle. And the circle is, area of the circle is pi r squared, which is pi, I don't have r, but I have h. H is the diameter, so it's 15 over 2 squared. Be careful again, this has to be divided by 2 because it's a half circle, or multiplied by half because it's a semicircle, right? So if I do my calculator work, it comes out to be 88.36. Finally, you add the two answers together, you should have 316.64 square inches. All right, so that's how we handle composite figures. Take your time, do not rush through these things. Take care, guys.